Very good evening to all. So it gives me great pleasure to introduce and welcome Mr. Gajendra Singh Raiput, a highly accomplished professional in the field of power electronics and control. Mr. Gajendra holds an MTech in power electronics from the esteemed NIT Puducherry and currently serves as a senior engineer power electronics and control at NTUPL Technologies, Bangalore. With his deep expertise in modeling, simulating, and implementing control algorithms for converters, inverters, and motor drives, Mr. Gajendra has contributed significantly to projects in areas such as renewable energy integration, microgrids, motor drives, and electric vehicles. His works with the indigenously developed FPGA-based RCP controller, WaveCT, highlights his technical prowess and innovative mindset. Mr. Gajendra's commitment to leveraging his knowledge to solve complex challenges in power electronics truly sets him apart as an expert and a leader in his domain. We are excited to have him with us today and look forward to learning from his valuable insights and experiences. With this brief intro, I would like to hand over the session to the key speaker.
So today the agenda is to discuss about more and more electrical vehicle is going on market. Like everyone want to work on electrical vehicle and how it is possible, like and what we can do in that and like as a research point of view. So we will discuss more and more like what is the research area we can go for that, as well as like how we can confirm the things like algorithm and whatever the topology we are. So before going to do anything, we have one thought in mind, like, okay, we need to do something. So before going to implement or before going to start anything, so we need to verify our thought, like it's kind of thought only. For example, like I want to develop one algorithm. So for that, what we are doing basically, we have to simulate that particular characteristic, that particular logic we are going to implement. So for that, we are using here MATLAB. Are developing whatever the algorithm someone want to develop, so they can simply develop that algorithm and it will give the confirmation what we are thinking, what we are going to develop. So it is going to be like confirm in the hardware also, kind of 100% confidence. Okay, so we can work on that because hardware will is going to take more and more time. So we'll start with first presentation. So I will give you a small overview of my company. So we are 11 plus here in this market, and we have a 120 plus team member. In that we have technical team, sales team, and other academic team. So in that we have been 150 plus corporate customer, and other is like we have a like supplied and the client is around 1500 plus colleges, and we have trained around 50K student, like that is BTech, MTech, and research scholars. So and some is professors also. And our research area, you can see we are working with different area. For example, academic, aerospace, training, research, and some other marketing things. So here, like some our domain specialization, we are working with a mechanical as well as CFD, EMAN system, VLSI, PCB, and PCB prototype, and adaptive manufacturing, VNA, RF solution, cyber security, Internet of Things. So if anyone want to know about this, so you can personally contact me, and we will help you out to go through these all domains. So today we'll go to for other thing, like we have our headquarters in Bangalore, and we have some other regional office across the India. So total office is 13. In that some are like NCR, Delhi, Pune, Ahmedabad, and Hyderabad. And we have started from 2010. So this is some of our business partner. You can say ANSYS, Anirudh, Cadence, Orchid, and this is partner. Like with them, we are working, and whatever the hardware and other thing is required for simulation things and other tools. So we have collaboration with these all partners. So whatever the things is required, we are using this. So now today agenda is first we are going to discuss about electrical vehicle drivetrain. What is the vehicle drivetrain? And I'm going to explain about electrical powertrain and direct real-time control operate in this type of system. And I'm going to explain a brief introduction of PMSM drive that is related to EV and some appendixes there. So let's start with our main topic. Like today, EV topic we are going to discuss. So how we can like how to approach this any particular topic. So here we have some different area. So where we can start our work. For example, if you want to work, if EV is not a one topic, it is having multiple combined topic. For example, if I'm saying here, you can see first is like we have wheel. After wheel will come transmission. So after transmission, we have motor generator. So why we are saying the motor generator? Because if you want to restore the power, like as a regenerative operation, so motor has to operate for as a generator also. So basically, we know like different type of motor nowadays in market. So some basic motor like DCM, induction motor, PMSM, SI. This is four basic motor. Apart from that, if you want to develop a motor which is not like our basic motor like in our syllabus, so if you want to like a EV is demanding some special kind of characteristic, like you can say someone is demanding more torque and high current. So like that is not part of our syllabus and that is not even available in the market. So if you want to test that motor, so we can develop that in a Simulink platform and we can use that and we can test it. Next is IC engine. So IC engine is separate. So here in electrical vehicle we have different module, like some is coming with pure EV, some is coming with hybrid model, some is coming with a mild hybrid. So that is you can go in, you can search in detail. All right. And other thing is come topology. So topology, like we know, like if you want to control the motor, definitely inverter will come into picture. So here we are using different type of converter. First is DC-DC converter. Very simple operation. You can take one battery source, like any battery source, and just you connect DC-DC converter. Just match the battery voltage to like operating voltage of your drive. Then it will become DC-DC converter, and simple by operating single switch and double switch, you can operate the your particular EV motor. Other thing will come with inverter. If you want to operate a, for example, three-phase motor, three-phase induction motor under PMSM BLDC, so simply you can use this inverter operation, and here you can choose the inverter. So you can work on inverter also, because EV inverter is not like our normal inverter. So here, once I talk about inverter, so inverter is like it is having high current, as well as when we know like when we need to operate with high current, so it has to go with uh, like when high current will pass, it will definitely generate the heat. So we need to provide that proper arrangement to the dissipate that particular heat. So, and that also one thing, like in EV, it's a movable vehicle, is movable things. So we need to make compact things. So for in terms of like we can't go for a very big heat sink, and we can simply like in lab, if you see the converters, the heat sink size is very big. So there is multiple topology for inverter itself. So in that field also we can work out, and we can think like, okay, how to design a compact converter which will fit with our application, which can capable to handle high current, and for that particular current which can dissipate that much heat for that particular time duration. Next we have multi-level. So multi-level is nothing but if you want to reduce the filter in some other application, as I told, if you want to go for compact thing, so this is one of the example, like you can go for multi-level converter. And other is like a comfort devices, like anyway, like we are going to operate a IGBT like a power tonic switches. So in that you have to select a proper switch. So nowadays different switches available. In that basic switches MOSFET and IGBT. So if you search, you will get some other switch also, like SiC switch also. So that is having a capability to dissipate high and high, like that capability to operate at high and high current. Next, if I talk about energy storage element, so energy storage also is one of the part of EV. So this is also one part of research. Like we can work more and more in energy storage, like how to, because everyone is nowadays, this is only the big challenge. Like everyone is demanding more and more backup, like in EV, some we are seeing some 400 kilometers, 600 kilometers. For us, it's just a battery storage system. So how we can utilize this, how we can storage more and more power in compact size. So when you are talking about EV, so every time for each and every topic, we need to think about compact and lightweight. So that is very important thing. So how we can make that? So that is also important here. Like in battery, we have one is called lithium-ion battery, lead-acid battery, and we have ultra capacitor and fuel cell. So this is an option like how we can use as per our application. For example, I can say ultra capacitor is having capacity which can immediately charge and immediately discharge, like it is having fast charge discharge rate. So here I can say if you want someone want to go for quick acceleration, so they can use two source at a time, like battery as well as ultra capacitor. So if you accelerate your vehicle within second, if you want to accelerate in that particular time, so we can use that super capacitor, and the remaining time for continuous power we can use our battery. So like this some combination we have to define, and we have to operate the our energy storage systems. Other is if you come for hardware, so we need to select like which type of controller we have to use. Like it's depend on user, so or like developer who is developing the algorithm. So it's just based on comfortability, like how is comfortable to operate, and at sometimes depend on hardware also. If you want to like operate a particular hardware which is having required high speed or low speed, so it's everything will come on hardware side cost wise. So there is some type of controller like MPU, MCU, DSP, DSC, or FPGA that is required. So this is related to controller, and software side, like you have to decide like based on controller we need to this is the things related to electrical drivetrain. So this is some topics are there, 5 6 topics. So here like we can start the work, and we can magnify more and more like in our research. So other, if I talk about like EV vehicle mode, so generally what kind of mode we need to test? If, for example, like when working with EV, so what is the mode we need to test here? First is called idling condition. So normal condition, uh, like in normal condition, for example, like I need to run my vehicle in a highway or some other case like a in no traffic area. So that time we need to run a vehicle at constant speed for a long time, like 1 hour, 2 hours. So in that case, I need to test my vehicle. So in that, what we need to test first, we need to test our motor, like whatever the EV motor we are using. So that is capable to handle that particular condition or not. Other thing like important is battery backup, like whatever the energy storage system we have, so that has to support, like for example, I want a vehicle who is capable to continuously drive for 2 hours. In that case, battery is very important, because whatever the power is required, it is supplying by vehicle. There is no, it is supplying by our energy storage system. There is no grid connect to the system like infinite source. So here we have fixed power. Like we need to define that, okay, I need to go for this particular length and this particular time with this power rate. So based on that, we need to define our power source. Next is acceleration. Acceleration, like how you are accelerating. So acceleration means, okay, within second I want to accelerate my vehicle. For example, I am saying in 10 seconds I need to reach 10 kilometer or 20 kilometer, like this. So like this is sudden power is required. So for that, our source has to support, our converter has to, because for sudden acceleration, definitely current demand will go more compared to normal condition or ideal condition. So that also we need to verify, like with our converter and controller and our drive also. Next is crucial condition, like steady state or moderate speed, like it will go up down up down. Right? Next is creeping, moving slow or inching like this. So this is also one thing. And this is creeping is nothing but a traffic condition. So when your vehicle is moving in traffic, so how it is going to affect for our system, so that also we need to check. Here we can save more and more power if you design an efficient control. That is called deacceleration. So deacceleration nothing was here, if we say about in terms of electrical, so it is just a regenerative braking. So like when you are deaccelerating, so if you go for mechanical braking, whatever the power you have used for acceleration, in mechanical braking, it will completely going to waste as a heat. But if I use regenerative braking, or like in downhill condition, so that time whatever the power we are using, we is stored it as a, we can say inertia power, that directly we can store feedback into battery, and we can save some power, and we can charge our battery. So this is related to this. Next, we'll give a small introduction about motors. Okay. So here you can see different type of electrical motors available, electric vehicle motor, but still some motors are remaining there that you can go and search. But this is just basic structure. So what type of motor is available? So based on our like availability in market, for example, one is having DC type and AC type. So in DC we know there is a lot of motor like PMDC, self-excited. This is basic, we know like series, shunt, and compounded, but this is just a syllabus. No one is using right now as a self-excited like DC motor, because DC motor having some own disadvantage. First disadvantage is like a if we are going for DC motor, brushed DC motor. So here problem is we need to continuously maintain the brushed loss on the brush. Because of brush loss, it will generate and so many things. So because that vehicle is going to be used for daily use, general purpose use, so we can't afford these things. So it's relatively tough. And I have not seen any like very few vehicle. Maybe it's old, but right now I'm not seeing any vehicle with DC motors. So if we come for AC, AC is nothing but nowadays I am calling as a multi-phase. Multi-phase means more than two phase. Okay, even two phase also multi-phase you can say. So here there is two category. One is synchronous, one is induction. Synchronous means like a motor is running with flex speed and lower than flex speed, so induction motor. Okay, so in terms of synchronous motor, we have different like reluctant, separately excited, or permanent magnet. So this is just depend on application. We know permanent magnet is having surface mount and inner mount. So now question will come like, okay, like if I have permanent magnet and if I can drive my vehicle with permanent magnet, then why should I go for separately excited in other reluctance mode? So what is the use of that? So we need to think out that, like for example, like permanent magnet is having own capability, like how much torque it can oppose, like how much power or torque it can support. So that is depend, like if you go deep of that, like it will tell it is mentioned like what is the maximum power rating or torque capacity we can design with permanent type of motor. So other case, like if you want to go for a high power, like in if I say for train application, traction application, so that time we need to think about that separately also. So to support them more and more torque sometimes. Nowadays, some motors are available which is having permanent as well as separately excited, both combination. Some synchronous type of motor is there, so that also you can check. So in upcoming slide, I will explain some new type of motor, so that also we'll see. Other is induction motor. Induction motor is our basic motor is available. So slip ring and squirrel gauge. So squirrel gauge is just for naming, but as we know, like it's very popular and it's popular because of its application. So I can say squirrel gauge is like one of the application, like it is having robust construction and robust operation also, both thing, and very low maintenance compared to all other motors. And like first of all, other thing, like if you talk about EV, so everyone want to know like if something happened and something this is the problem, who will rectify my issue? So induction motor is a very basic in that is 12 gauge, so anyone can rectify. Slip ring in just for naming. So if it's required, we can go for a special case. If seriously required, then we'll think of displaying, because here also some brush loss will come. So this is some electrical motors in global drive trends guys are using. First, you can say permanent magnet motor. So here you can see design of the motor like inside and examples like who is using this motor. So first you can say BMW i3 is the one of the model is using permanent magnet motor. Other is YD E6 and Cherry EQ, and induction motor. You know Tesla Model S. Everyone know this is very popular vehicle, and Renault Twizy and Twizy is EC180, and silent motor. So this is using by Renault Joy and Renault Fluence and Smart 42. Okay, so this is some motors is actually is using by some EV vehicles. And other, let's talk about little bit about batteries. So what type of batteries available? So which we are using, that also we'll discuss. So here we have some basic types of battery, but we are not using all right now. First is Panasonic type nickel. This is designed by Panasonic. It's example. So nickel metal hybrid, one of the type of this rechargeable battery, and other is nickel cadmium. So this is just like they are playing with kind of material, semiconductor material. So one to other one is lithium ion battery. In lithium ion also we have so many things. Nowadays we are using lithium phosphate battery, because lithium ion is having very fast charge and discharge issue. So it is having kind of, we can say, small kind of blast and some cases scam. So that's why guys are shifting now for lithium phosphate. Okay. And our future is for Terra 3.0, it is solid state battery. So that is not in market now, but still research is pending in this. But this is, we can say, if we can implement the solid state batteries, so this is one of the best energy source we can implement for our batteries up to now. But future can anything, so it can we go for some other way also. And this we know, like our lead acid battery is common battery. So some small vehicle like auto rickshaw and some of the local vehicle, they are using still lead acid also. So that is common battery. Now discuss about powertrain. So what is the electric vehicle powertrain? As I told, like we have so many area, but as an electrical point of view, what's the powertrain is available in vehicle? That also we need to look once. So here you can see in powertrain, first of all, we have battery. So battery, as I told, we can go with anyone, like as I explained previous. So right now we are using lithium ion, lead acid, or lithium phosphate, three type of battery. And sometime if it's required, in parallelly we are using supercapacitor also. So as we know, like a battery having one, like if you are designing from your end, so you can connect directly battery with converter point, because we know, like okay, our motor is designed for 60 volts, so I can take 60-volt battery and directly I can connect with motor. That is a no issue. But problem will come, like if you want to go for regenerative or some other application. Okay, I want to limit my power, so I want to send only this, because motor don't know like how much power we need to, how much power is required. So that power is going to decide by load side, and our load is vehicle weight and that vehicle road condition. So from these all things, it will decide by other end, load side. So now if I want to control that, how much power we can provide, so that for that purpose we need here DC-DC converters also, like to match the voltage level, because our battery is because we know like battery voltage is floating voltage. It will float from some, for example, if you have 72-volt battery, so definitely it will float from 62 to 82. So whatever the real time parameter we have observing, that I am talking, like for 72-volt, this will vary. But our motor is designed for a constant 60 volt. If I want to use my motor for like a all time full efficiency, like I want to operate with my 60-volt rated, so that time we need to use DC. Otherwise, this is not compulsory things. If you can operate your motor in this range from 60 to 82, so it's not a problem. You can directly connect. You can skip this DC converter part. So here battery and converter and direct propulsion type motor will come. So like this you can define, and like get transmission to just uh, efficient the power. That's all. And as I'm saying, like once you talk about any converter or battery, like nowadays everyone is using lithium ion and lithium phosphate battery. So we know these batteries are very sensitive with respect to temperature. If I say for charging, discharging, here if I charge my lithium ion battery, so it can take whatever current I will supply. It's not a problem. So here in charging, discharging, both case same condition. So now I want to limit this. We need to first verify. Like okay, as I'm saying, like for example, like my battery is having a rating like 50 m. So we need to define somewhere, like we need to check like okay, my battery is charging with 50 amps and it discharging also 50 amps like this. So that somewhere we need to know, and someone has to continuously monitor that. So to operate these all things, then only I can say my battery storage line, what were the lithium and lithium phosphate is working with in safe operation. So for that we need to take here voltage and current measurement. You can see here this voltage and current we need to measure. Yeah, this one we are talking about in this slide. So here you can see same thing for converters also. If you want to operate the converter, so first thing, as we know as a electrical point of view, first we need to take the input signal, then we need to take feedback signal as a output signal. Both can signal we need to observe and we need to understand. Okay, this is my input, this is the output is required. So now how converter has to operate? It has to go for buck operation, it has to go for boost operation, because nowadays multiple topology are there. We can operate a converter in buck converter also, boost converter also, or buck boost converter also. So this is the multiple topologies there. So for that we need to understand this. So that also we have to measure the signals. And other thing as a propulsion drive, so first we need to understand the demand from load side. Based on demand, we need to, in simple way, I can say we need to define the modulation index of the drive converter. Okay, so for these all things, how we can define in real time. So here you can see I have plotted some signal. So first I am taking voltage and current signal from battery because I want to know the status of battery, like is this working with my operated condition or not under my operated condition. And here you can say I'm taking some voltage current signal from my motor side, and based on that my input and output signal we are generating here. So here you can see, like in that way, I am controlling my like this is the basic operation is required to operate any particular converters or like to operate any particular hardware. So here I'm using speed sensor also to know the speed. So this is in terms of electrical, something we are converting into like a user point of view, we can say in display. So whatever the signal is coming, we can show in display. So for that, here what we are using actually, here we are using one of the real-time controller, direct real-time controller is having FPGA as well as ARMS controller. So this will help out to do these operations. Like for example, if I want to go for measurement, and if I want to generate some control signal also like PWMs, and if I want to display some, so this is having capability. So it will like just connect with any display or your system like your personal laptop. So there you can see the all type of live data like these signals like PWMs, voltages, current, speed of the vehicle, and you can like operate this in real time itself. Like you can change the value like speed reference, and if you're working with any closed loop operation, so that also we can operate. I will show you in a MATLAB model also, so how we are doing that. Okay. Next one, you can say this is a test setup using by us like interval technology. So like define any particular to test any EV like a application. For example, like if we want to test battery or any motor and other thing. So here what we are doing, first we have a battery. So battery, we have different type battery. We have lead acid also, lithium and also lithium phosphate also. And it's like if someone want to work with is a emulator, like a fuel cell emulator. So these all things option is also available. Next, as I told, we have propulsion drive. In propulsion drive, when we have DC-DC converter, that's not compulsory. It's depend on user and application, like depend on battery and like a motor. So based on that, we have to define we have to use or not. Next, we have propulsion drive converter that is compulsory. And next onward, if I see the propulsion drive motor, that is my EV motor. And next, I have my torque sensor. So torque sensor is to estimate the real-time torque. Next, I have induction machine. So here I am calling induction machine because I am using this as a motor as well as generator. So next we have inverter and front-end converter, and that front-end converter is we are using to operate with grid. So here if you see from battery to grid side, like battery to front-end converter side, so this is one way of low to power. So if I'm like if I want to test my battery and motor for a long time run or a sudden inertia, like as I explained, like acceleration, deceleration, these all things. So here for continuous run and acceleration part, so power will flow from battery to front-end converter side. So whatever the power like we are using to test that, because like EV is designed for a long time. For example, if you want to test my vehicle for 6 hours continuously full load, or no one will run for 6 hours, but for example, okay, real time data is like 3 to 4 hours, anyone can run. So in that time, if I want to test my vehicle or battery backup, so what we'll do, we'll take power from battery power source only, will drive our motor, and we have our induction machine. So it will help you to generate the like load the electrical motor, like EV motor. So based on that inverter operation, it will send power to grid. In very simple way, whatever the power we are using to test the vehicle, we are sending to grid. Except mechanical losses, like we are not wasting any power. For example, if I'm testing my vehicle, so I can say only I am wasting 10% power, 10 to 20, 10 to 15% in loss of as a mechanical. Like we have, because we have air coupling and some other converter loss, and if you consider, so overall maximum 15% loss is there. Remaining 85% power we are sending back to grid. So in that case, you can test your vehicle for long time. This is one of the useful setups. And other case, like if I want to test my vehicle for regenerative, so how we can look? We can test take power from grid, and the same power we can feed to battery. So if you see simple operation here, so first we have propulsion drive motor. So if I want to load this motor, so next machine has to work as a generator. Other case, like if I want to test this machine as a test this particular setup for regenerator, what we need to do, our motor has to work as a generator mode, then my induction machine will go for motoring mode. So this is vice versa operation is there, so that we need to decide with controller. So here you can see same thing, like I am using here a real-time controller. So this is nothing with Bevec real-time controller, and for communication and other operation we are using here our system. And here I'm just taking feedback. Like here we have CAN communication also. So CAN interface, in that like you can monitor the battery data like temperature and battery voltage, current, SOC. These are things we can easily monitor and we can operate also. Monitor is one thing, like we can operate like we can operate real time. For example, like I need to charge my battery faster than fast. So what is the parameter is affecting for fast charging? Because battery never ever say no, I don't want this much current. So battery can work for any current, it's not a problem nowadays, lithium ion battery. But here, like when you try to charge battery with high current, it will raise the temperature. So we need to continuously monitor the battery temperature. Based on that, we can define, okay, my battery temperature is rising, slow down the current. Like this, we can, if someone want to quick charge, for example, uh, like for charging station, someone want to, he don't want to charge battery for long time. He want to quickly charge some 10-20%. So what we can do, we can immediately go for high current, because that time we are not bothering about temperature. Because for 10 seconds, we know like we are continuously monitoring temperature want to go beyond the limit. So we can charge. Like this, some situation is there, so in that situation, we need to deal with multiple parameter of battery. So this CAN interface will help you out to do these all things. So same way, like if you want to control the converter like a front-end propulsion type drive or emulator. So for that, we have multiple PWMs here in this converters. Directly you can connect and you can run this. Here, next, as I'm saying, like this is a controller we are using. So now you can say like one of the we are going to discuss about this basic of controller, like what is inside the controller, how is going to help you out, because we know about hardware, we know about other thing, but once it come for real time system, so how we are going to implement and how it is going to help. So let's take an overview of controller, Vivek real time controller. So here I'm proposing this Vivek real time controller. It is having rapid control prototyping solution for power tools application. Here you can say and down, like we have a tested this controller in multiple fields. For example, if you want to operate in wind application, solar application, so this, because if you go for EV, in that we need to design one charging station also. So charging station is the part of solar as well as wind power, because nowadays power is demanding more and more. We can't just go with we can't only depend on grid. So nowadays, because of EV, renewable source demand is coming into picture more and more. So this is the some extra power we need to generate to fulfill the power demand. So here we have wind application as well as solar application. And if you go for microgrid, so this is just like a you can design a microgrid, a small microgrid. It's depend on user and other thing. So here you can generate the power. You can in small house also you can implement one power plant and wind application. So here we can generate and we can charge our vehicle. Next, we have tested different like all types of motor we have tested here, and power quality. So when I was taking power from grid, so we need to worry about power quality also. So we need to maintain that THD like grid waveform. So that thing, and other is like charging application. There is last one. So this is the like basic architecture of Webex real-time controller. So as I told, we have FPGA as well as dual core ARM processor. So that is having one SoC, Zinc SoC. So it is a fully user control function. So whatever the things we are using, so here we have both operations like FPGA as well as DSP. So user can operate DSP as well as FPGA. If user want to develop their algorithm in FPGA, that is also possible. We will allow that. And if user want to develop an algorithm in DSP, so that is also one variant. So here we can operate in DSP. So basic things you can see here, virtual plant model. We need to create one virtual plant model. So that model we need to verify it in MATLAB platform. As I told, like whatever the thought, what is the idea we have to simulate and we have to verify in simulation platform. Once it's ready, we need to generate the control and we need generate the binary that we have to upload into controller. And IOS communication like PWM and ADC, voltage, current. So we can work with real-time plant, or if you want to you can go for HIL plant also. So it's depend on user. So here I will say some special features about real-time controller. First we have fast step time. So that fast step time is nothing, is like we can start from 5 nanosecond. So it's depend on user to user. If you seriously if you want to go, so this is the fastest time we can operate. So here with 5 nanosecond you can generate up to 2 megahertz switching frequency, and other like 10, 25 second, because in hardware this is fast time is not going to like affect anywhere. So if you work with 5 nanosecond also or 15 nanosecond also, and nowadays we have fast time in microsecond also. So here, like if you go for simulation, if you want to verify simulation, so same time we need to think about fast this step time, because it is going to affect on simulation, because we know like if we use a, this is just nothing but like, for example, I have some data. uh, Step time is like, for example, I need to process one data for a second. So if in a second, how I can optimize my data, like how I can understand about this particular signal. So if I take 10 sample or 100 sample or 1000 sample, that we need to decide based on our signal. For example, if I want to understand any sine signal, for example, my real-time voltage. So in real-time voltage, we have 20 millisecond time for a type 20 millisecond time period. So in time period, if I want to plot my complete waveform, so how we are going to take? So minimum like 10, 20 sample is required. If you want more and more precious, we'll go for more sample. It's like that. Okay. And other is like high speed IOs. High speed IOs, we have a total 128 user programmable IOs. So that is independently user can configure. We have embedded voltage sensor, current sensor, PWM. In the upcoming slide, we'll discuss detail also, like what is the meaning of embedded voltage sensor, current sensor, PWMs, analog input outputs. And we have flexible slot based structure. Here you can see. So first we'll understand, because this is the main difficulty, like okay, somehow I can develop my algorithm, so how I can go for hardware, how I can test in hardware. So here you can see we are providing here model based design. What is the model based design? So here we have to choose a platform. Here we are using MATLAB Simulink platform to develop the algorithm. So we are providing here two type of flow. One is HDL flow as well as XSG flow, Jiling system generator. So what is supported by Abevec. So here we no need to do any kind of a manual coding. Just by single click you can generate the binary. You can generate the configuration file. Okay. So other thing like we are providing here Abevec suite software. So that will help you out to understand the hardware, like debug the signal, to operate the signal, and so many things we can do with this Abevec real time Abevec suite software. First thing, like we can control function tuning, like whatever the control algorithm we are operating. If you want to tune that, we can go for control function tuning. Other is like analysis. Analysis means if you want to see any particular voltage signal, current signal, waveform, as well as RMS value, average value, so that is also possible. Same time, if you want to log the data for future analysis, or if you want to store this data for other comparison, so that everything is possible here, like all type of data logging, in which format we need to select the data. So it is program and manage the Vivid controller. So whatever the program you have, and like easily it will control the your controller by using this Vivid software. Okay. So there is only four key point: real-time controller, real-time signal software, model-based design, and we are providing our library in that you will get our apps and iOS reference designs. Next, once we come for electrical system, so important thing is here, like if you operate any particular hardware, so safety is must. So we need to think about this more and more. So as we are operating from more than 10 years, so whatever the safety is required, we have already implemented here. So if other thing is required, we is always free to upgrade the things, and we are always happy to see the feedback and to implement that useful feedback. So here you can see we are providing like a over voltage, over current, under voltage, under current, and that is configurable with low and high threshold and instantaneous definite. So here in protection, in simple way, I will explain with a model. So for example, you can take a motor. So like our motor is designed for 10 amp. I can say my motor can handle up to 12 amps because its rating is 10 amps, but it can handle up to 12 amps. But how long? That also one is with respect to value, with respect to time. Like we know our any motor like induction motor or any other motor. So if it is known like okay, I can draw 12 amps up to 10 second or 5 second. That time we can define here easily. I can define okay, my overcurrent protection is 10 ampere for 5 second. So if it is go more than 5, because we know in for a small time it can go 12 ampere, it's not a problem. Rated is 10 is fine, but for some time, for a small time, 2-3 seconds, it can go 12 also. It's not a problem for my motor like this. So that I can't consider as a fault. That is a normal situation. And if you suddenly accelerate, we know like at standstill condition. Standstill condition, motor will draw more and more current. Like as per theory, like it will drop 1.5 times operated current. So that is normal case only. It's not like a faulty condition. We have to allow that. So for that, we can configure this fault based on this. So this is called definite time mode. Other is instantaneous mode. Instantaneous mode, for example, like I am working with converter, and we know like in grid connected converter, what will happen? Like if you try to operate that front end converter, immediately my some DC capacitors are there. So within second, it can boost for 800, 900 or 1000 volt also. So that we need to protect. If some failure, for example, if hardware is old and if some wire is loose, another thing because of that, or during testing condition or developing time. So if anyhow that I can if reaching for that more than limit condition, like my capacitor, DC capacitor is designed for 900, so we need to protect around 850. So here we can define instant like in microseconds. So minimum time here is 5 microsecond. So after that 5 microsecond, 10 microsecond, 20 microsecond, like this we can configure. So this is called instantaneous mode. Even right side you can see this is my faulty condition. So in like you can consider this is my current. So slowly it's increasing. Once it's reached for fault, it will trigger, and within 5 microseconds it will turn off the PWM within one cycle. Okay, here we have buzzer output also, that is also configure. Like for example, this configuration means like I want buzzer when my fault come, or else I want buzzer when this condition happen, but it's not a fault. I want to know my motor is reaching more than 10 ampere, but that is not a fault. So for that, just we can enable the buzzer output, but and both also is possible. So these all things are easily possible with suit libraries blocks. And we have fault indication. So once fault will come, so easily you can come to know where is the fault by seeing this indication. So we have fault indication in backsuit software. In software itself, we'll understand this. Okay, this is my fault location. For some 20 sensor, in 20 sensor, where is the fault? How I can know? Because buzzer is common for everything. So here, by knowing that particular number, okay, this is my fault. Like for example, my fifth sensor is having fault. So like that, we can understand in Berkshire software. So this is regarding protection. So how to operate this, how to do this. So we have our support, and this is always as a part of training. So other you can say as I'm doing flexible IO. So what type of see this is flexible IO means like if you are working with any kind of application. Here we are talking about EV, so I will focus more and more EV only. So for if you want to operate any particular EV application, so here what we need to do, first we need to sense the voltage and current. So for that we are providing voltage sensor. We are calling is a VI sensor, voltage and current sensor. Next, if you want to operate any converter, so we need to generate the PWM. So we are providing here PWM physical port. And if you want to see any analog signal, for example, if you connect any torque sensor, so torque sensor is generating analog signal. So for that we need analog in. And if you want to operate some hardware that is required analog signal, so we can generate that analog and we can fed that and we can use analog out. Same thing, digital in, digital out. And if you are working with EV, definitely we need speed also. So for that we have a differential type encoder. This is about controller. So here you can say is user configure like We can supply here up to 128 IO so that you can configure like voltage sensor, current sensor. So in which way you need to operate, we can go with that. User can customize the IOs card as per requirement, and we can select the slot. We can have programmable result. We have a dual 1 Mbps scan interface, and this is you can see like a IOS card available on the controls. Now, once we talk about sensors, embedded sensor, current sensor, so everyone will ask. So here you can see if I talk about sensor, so everyone want to know what is the rating of sensor, up to what rating we are supporting. So here I can say whatever the real-time data is required to monitor and whatever the application is up to now is we are using. So based on that we are using here embedded sensor. So this is one of the sensor like voltage sensor, current sensor, high current sensor, and analog input. Here we are supporting up to 16 maximum channel. If you want, you can go for more also. So all sensor are isolated type, all voltage sensor, and current we are providing closed loop flux gate sensor, AC plus DC volt. So in high current sensor we have closed loop Hall effect sensor, AC plus DC, and analog in we have isolated voltage sensing. In voltage range we have plus minus 1000 volt instantaneous, and in current range we have 25 amps RMS and plus minus 80 amps peak current. High current sensor we have 200 amps, 300 amps, so that is supporting up to 400 and plus minus 800 measurable range. Analog input we are supporting plus minus 10 also, plus minus 100 also, and bandwidth it's up to 262 kilohertz for voltage sensor. For current sensor up to 200 kilohertz, and for high current sensor voltage sensor you can see here we are providing up to 100 kilohertz for 200 and 500 up to 200. So this is for analog input up to 260 like as a voltage sensor. And we are using here delta sigma type ADC, resolution bit up to 16 bit, and sampling rate up to 1 MSPS. 1 MSPS is maximum, like 1 mega sample per channel. We can like this much data we can optimize within a second. If you want this customizable, like you can go for 200 kSPS, 100 kSPS, 50 kSPS. So depend on requirement, we can go for subsamples also. And the sampling time we are using a simultaneous, and this is just regarding hardware that thing. I also expect like here voltage sensor and current sensor. So backside of controller, so we are providing here. So here directly you can connect your voltage and current signal. Other one will go for PWM card. So PWM is like a whatever type of converters available in market. Based on that we are supporting here three voltage level. One is 5 volt, 15 volt, and with a digital IO pin we are supporting a 3.3 volt. So this will cover all of the converter which is available in market. You can see here through program itself we can change the 5 volt, 15 volt, and supply is like by default we are providing here 500 milliamps per channel. If someone want to go for more, if someone driver is demanding, this is enough to drive any particular power electronic switch. If someone want to go for more current, that also option is there, we can provide it more current also. And analog output card, so this is have something like a range in plus minus 10 volt, 16 bit resolution up to 200 kSPS, and settling rate here we have within 15 microsecond. Digital IOs, you can say here we are working with 3.3 and 5 volt. So this is also selectable. We can select 5 or 3.3 or 5 volt both in input and output. So here other is like encoder. As I told, we are using differential type encoder. So it will help you out to compensate the like noise. If you are working with any particular hardware, if you are using 3-4 meter length wire, so that will easily compensate here. And we are providing here SPDT relay, NONC relay. So that relay will like if you are using for any kind of protection or other thing, that will help you out. Other thing you can see, we have like a overview of that IOs. So you can see in top we have ADCs, and front we have PWMs, physical IOs, PWM, and digital in, digital out, and communication port like CAN communication, and other is RS communication, RS 482, and other communication. And here we have uh, Ethernet port to communicate with controller. It is 1 gigabyte Ethernet port. So now if I tell about Worksuite software soft code, so here we have three blocks that we that is helping other than hardware to develop the algorithm in MATLAB platform. First one is iris. For example, uh, if you want to for example, if you want to operate in simple way, I can say like whatever the signal you need to operate in real time, just we need to connect through iris. It's called in, you can say input register also. So like in processor, some registers are there that is designed to store the values, kind of that only. So what is the real time tuning? Uh, like initial value and some limits are there. So it is just to operate the real time data. So we need to go through with iris. In probe section, like whatever the signal you need to observe, whatever the signal you need to analysis, whatever the signal we need to plot or compare. So that all signal we need to connect with probe. So once you connect, we can select the sample rate 50, 100, 200, 400. So this is based on your system speed. So there is no missing sample, like whatever the rate you are selecting, it will continuously pass and you can understand, observe that. And other thing, iTable data, if someone want to operate systems of Excel sheet data, so that is also possible through iTable. That is also one thing. Now, this soft code, how it will help, we can say here. So once you go for real-time system, here we can say we can edit the text field. We can take as a button, like right side you can see some buttons are there, and then small dashboard as a text field, and you can change the color also. We can display in different way. So this is for IDIP, and thing for probe also. You can plot in time plot, like we have our time plot. So in upcoming slides I will tell you or show you what's the time plot and other values. So we can save this data, save it like you can save as per requirement, like you can save as a CSV format, picture format, or other format also. Okay, so as per requirement, there is multiple way to save the data so that we can operate here. So this is one of the features in VxShoot software. Here you can plot your signal. Whatever this is, you can see continuously we are showing in one video. So how you can play with one time plot. So what we need to, we need to select one time plot, drag and drop the signal. So once you have the signal, you can analyze this signal in different way. Left side, you can see we have three signal in one plot. Like this, we can take up to 8 signal and we can compare. Here we can change the color. We can go for line plot, dot plot. We can save this in a picture format, CSV format. You can pause the data, or these all things like as you're seeing. So up to 16 number of plot we can select in for one operation. That is more than sufficient. Next, we have general plot. So previous plot is signal versus time. So this is signal versus signal plot. So for example, like if you want to plot speed versus torque, in motor case, generally this thing is required. So in x-axis, you can take speed, and y-axis, you can take your torque. So speed versus torque, you can plot easily. So like this, Sam, you can save the data in terms of CSV format and other format also. Here, Sam, like up to 16 number of plot we are allowing, and up to 8 like in one plot, we can go up to 8 signal. Next is FFT panel. So this is one of the important panel we are supporting here. So this is like if you want to go for any kind of power quality or harmonic analysis, other thing. So we have to use this. So basic thing, we need to just drag and drop the signal. So it will tell the fundamental frequency. What is the fundamental frequency? What is the THD, total harmonic distortion? What is the distortion factor? And what is the contribution of individual harmonics? So right side you can see. So once it go for report section, and other thing like so we can understand like what is the contribution of, like for example, I have some total 10 ampere magnetic current. So in that I want to know what is the contribution of third harmonic, fifth harmonic, seventh harmonic. So based on that we can design the filter. So if I know the exact value, we can we can optimize our filter. So that will help you out. So by default, it will show up to 13th order harmonic. If anything is like if someone want to define some other frequency which is not available, so user can easily define and he can understand the. So this is one is useful for power quality to understand the quality of waveform. Okay, we're working with a AV application like a I can say in charger we need to define a good THD charger. So these all things will help you out. So next is power panel. So as we know, we are working with electrical system. So power is very important. We need to understand how much power is, like if I want to know what's the loss, how I can define like, okay, what's the power we are sending from battery from one end to other end, like my battery to motor drive, how much power, so how much power is consuming my motor, so that easily we can, if you have real-time data like real-time signal voltage and current, so we can create some different type of power panel. In that we can check active power, reactive power, apparent power, power factor, and instantaneous power, and we can see the phasor diagram. Okay, so here you can measure in different configuration like single phase, two phase, three phase, four phase, and DC power. If someone wants something special, so we have for that also extra provision. So here you can design on expression panel, that will come in other section. Next is power analyzer. For example, I have one power panel. So now I want to know what is the terms of power, like what is power for third harmonic, fifth harmonic, seventh harmonic. So that also we can define here by using this power analyzer. It's very simple, like our FFT panel. Okay. Now I will explain a very small thing about model-based design. So this is our main thing on the topic. You can see right side I have I'm showing one model-based design. This is just a PI controller. So in PI, what we need to do first is reference signal and actual signal. So I'm generating here error signal. That error I am multiplying with KP. So KP, this is my error with KP. First multiplication. Next, same error I am multiplying with KE, KI, and this is my integrator. Once I enable, it will pass, and my KP into error and KI into error with integration. So it will pass and it will generate my PI out. This is one kind of model-based design. So whatever the mathematical equation you have, like we know our PI equation. So based on that, by using basic blocks, we can develop here any algorithm which is having mathematical equation. So like this, you can generate and you can test in MATLAB. So what we need to do first, here we can use HDL coder library, or as if you are working with DSP flow like in DSP, we can use Simulink library also. Okay. So what we need to do, we need to simulate the control function with the plant model. Plant model, like if you are working with motor, so we need to take motor as a plant model and we need to develop that algorithm. So once that is ready, we need to verify our algorithm. Once it's working, we need to generate the binary, or we need to upload it to controller and to test with hardware if we have that hardware. Okay, or else you can test it as child model. If the plant is very, for example, like I want to develop control algorithm, power flow algorithm for a enter particular state, so we can't go and test in that particular region. So for that we need to go for HIL model. So this is like overview of model based design. Here you can see in first red color region, this is my control plant. Okay, and outside we have Bebek based library block, so that is required to define the output ports, IOs port. Another I have control, so this is my converter, and last I have my motor. This is very basic, like we can develop here entire EV system, like to test my battery and converters and my motor, everything like based on high current, high temperature, these are things. You see. Here you can see this control plant. Okay, control plant and plant. Other thing, so how our Vivek suite is supporting. So here in by using this software, we can go for control tuning, we can go for analysis, and we can go for measurement also. We can go for expression also, data logging also. I can create a nice dashboard. So I will show you like what is the dashboard meaning of dashboard here. I can go for control management, and we can write a script. So this is heading by interpreter. So this is my GUIs. You can see here. We are providing here. So you can see like I am seeing some waveforms here, as well as we are seeing some measurements like RMS value, maximum value, minimum value, average value, and we have some enable disable operation like turn on, turn off, and I am comparing some signal with multiple signal, and we can add some pictures also in that to express our control topology. So this is regarding wave controller. Now I will show you in MATLAB how we need to interface this with our control system. So this is some research solution we have developed, and we have we can say we have tested with this particular real-time controller. And so first, like all type of electric drive what is available in market. If someone is new also, we are always testing, and the research is going on device days. So first is like PMSM motor drive, BLDC drive, induction motor drive. In that, as I discussed, scroll gauge and SRM, and SRM motor drive, DC motor drive, regenerative loading for AC/DC motor. So that's also we have tested. And EV motor charging system, EV motor drive with loading meters. These are things are there. Next is research solution we are providing here in terms of renewable energy system. So here we have DFIG based wind emulator, PMSG based wind emulator, grid connected solar system. So grid connected PV solar and AC/DC micro variant, active shunt filter, and UPFC, DVR, STATCOM, and grid regulator. So these all things nowadays is, and I think is different. All are common because if you are going for EV means definitely we need to design a EV charging system. For that level, we need to consider. And once you go for a high power exchange like with grid, definitely we need to think about power quality. So this is a common topic. All we need to understand. Here, I am going to going to give a small introduction about PMSM on drive, how we are going to control it, what is the basic things required to control a PMSM motor. So how our controller will help and how MATLAB will help and to design and to test this drive. So in same way, I shown in my previous slide. So this is easy. First is you can say this is the system architecture in hardware. What is the thing is required? So first I need supply, that is to test, or you can instead of supply you can use battery pack also here, energy storage system. Next we need one converter, that is like AC to DC converter, that is up to us is required or not. And next we need our PMSM motor. So and to control these all things we need our pivot real time controller. So here we are taking some feedback signal, voltage, current, and speed, position, and we are working with PWM. We are generating the PWM to operate the converter. This is the basic things today I'm going to explain. So you can think we have one motor and one converter and one controller. So list of equipment. So this is real-time controller having advanced processing, voltage sensor, current sensor. So that will help you out to estimate the voltage and current of motor as well as speed. And we are using here PMSM motor. So that is we have up to 3 kilowatt. That is having 60 volt DC and 60 amps. So it's high current motor. You can see in EV. It's running up to 3000 RPM. So it is having Hall sensor, but we can operate without Hall also. So for research area, like we need to understand both how motor will behave with this position sensor or without position sensor. So what are the algorithm I am going to present today? That is the sensorless PMSM. And to operate to control this machine, we are using here uh, rectifier with IGBT based inverter. So that is the hardware part. So today part is just for simulation. So we'll see. This is my control algorithm, MATLAB model. You can see. Okay. So here you can see this is blue color. What I am showing, this is my control algorithm, and other you can see green color is my converter part, and the dark gray color is the motor part. And outside I am connecting some outside my Bivec based IOS block. So that will help you out to assign the any particular physical IOS like voltage sensor, current sensor, and PWMs and other things. And this is my control model inside the subsystem like control system. I have open loop to closed loop transient. Like if you go for sensorless controls, what we need to do we need to know the rotor position, because PMSM BLD this is a special type of machine. To operate that machine, rotor position is essential. We need to know that, like, so for that we need to run the machine. So initially it will start with open loop, and that we need to decide like to how long we need to run, like how we need to switch from open loop to closed loop, so that we need to operate. So that time we have to decide here in control system. So this is called of transient time. So initially it will start with open loop, and after some time it will reach for closed loop. And next is speed control, and like speed loop, you can say speed loop also, speed control also. This is my outer loop, and next is current control, that is inner loop. So I am implementing here my vector control like FOC of PMSM. Using like sensorless topology. So this is the basic architecture like control topology we are I'm using to develop this. So inside the plant model, what we have? So first we have supply. In MATLAB simulation, you need to check the supply: three-phase power supply, three-phase rectifier, DC link, as well as three-phase inverter. And like you can take motor, whatever the motor is required, BLDC, PMSM. So you can select in simulation platform itself, and you can choose this motor. And if you want to work with Hall signals, you can take that Hall signal also, or else you can go with sensorless also. So that is up to us. So this is in MATLAB. First, we need to like if you want to go for step by step, also it's fine. Otherwise, you don't want to take three-phase supply, you can go with directly battery fed. So you can connect a battery, so this rectifier part will go up, and directly you can connect to three-phase inverter. So that is also fine. Like here also we can simulate the characteristic. Now our work is like if you want to work with a three-phase inverter, to how to control this special machine and how to know the position. And nowadays sensor is very tough, because Hall sensor is very sensitive with respect to water as well as dust. So everyone is demanding now sensorless control. So we can work on that, like how to know the sensor position, because we need to implement that mathematical equation, and so many things. So it is like tough to understand, tough to work with sensor now. So like we need to and for sensorless there is multiple mathematical equation. So now what we need to do, we need to that equation we need to develop into control topology, and for that we need to generate the code. If you go for like old way, like to write a code, so complicated to write a code for equation. So better like we'll go with model based design. So here directly we can implement. And here one more thing we are verifying in MATLAB. So thing is like how I need to verify my data, like input to output. Like, okay, I have some reference, based on reference how my model is behaving. What is like as I am developing, so I know what is the required output for me. What is not coming is what is the things we need to fix. So here itself in MATLAB itself we can fix the like data type, other thing like my data is processing properly, no? Because sometimes we know like my algorithm is fine, everything was why not is working. So how we come to know? In hardware we can't understand this thing, but in simulation easily we can track, and we can come to know where is the problem. So by point to point analysis we can understand where is my data, and where is going this wrong. So this is regarding today topic. So if anyone having any query regarding any slide, so all are free to ask, and I will feel happy to resolve this issue. So from first slide to last slide, if anyone having any query, so you can ask me.
Sir, I am Perichiappan. I'm a consultant. Regarding this, nowadays the vehicles are getting firing and all the incidents happen like that. Any temperature control is there? So far you have given only voltage and ampere. This has been converted into temperature, converted to voltage and ampere, or temperature. You got any controls there?
Yes, sir. See, as I explained, we have here CAN interface, CAN communication, and nowadays whatever the battery, if you take wood company's battery, so they are having like BMS module. So through in that BMS having CAN communication or some other communication, whatever. So we have all type of communication channel. So easily you can monitor the temperature, battery temperature. So that temperature you can easily monitor, and as I told, like you can decide, okay, I need to charge or discharge my battery for this particular temperature. For example, my battery is designed for 80 degrees, so I can set the limit. So my battery has to work for 75 degrees. Once it reaches more than 75, it has to turn off. Like that command we can set here. It's very easy, sir.
Okay, thank you, sir. My question answered.
Yes, yes.
Participants, if there is any query.
Sir, good evening, sir.
Good evening.
Yeah, sir, regarding the last slide, first of all, your presentation is very good, sir. I asked a few queries. So in this last slide, you are talking about the three-phase supply and also rectifier, inverter, and also BLDC motor, and also again some motor. See, you take say finally your motor needed only AC supply.
So you're breaking, sir. Hello.
Yes, sir. Yes, sir. Actually, here, you're taking the three-phase power supply.
Correct,
and
sir.
You're converted to AC to DC converter, and also from the DC converter, you're taking again go for the DC to AC.
Correct, sir.
when you're going to talk about the hardware model or hardware setup or any electric vehicle, so
Yes, sir.
what the purpose of here using the rectifier, sir, and sorry, inverter?
Yes, sir. Yes, sir. I will explain here. So this is just a basic architecture. So you can skip wherever you want. Like for example, we don't want three-phase AC power supply. So I can say like this is EV is not a one topic. For example, you need to work for only motor, correct? So for motor, I don't want to buy a battery or other thing. So I can directly take supply from grid, and that power we can use, like we can convert. This is the one flow. Other flow, like if I want to use battery, so what we'll do, instead of rectifier on three-phase supply, we can remove this and we can connect our battery directly to this DC link part.
Yes, sir, exactly. That's my question only.
So no need to use this. This is just architecture, sir. Yes, yes, sir. That is not compulsory, sir. This is just basic architecture. So like this is the if someone want to test only drive, as I explaining only drive, so I'm not considering my battery source here.
Yes, sir. And sir, second thing, sir, here you're using the either rectifier or inverter, you're going to use the pulse signals. Pulse signals.
Yes, sir. Sir.
For rectifier or inverter, you're going to use pulse signal for the S1 to S6 switches. In the
Yes, sir.
So you're using the PWM.
Yes, sir. PWM only.
Okay.
That topology we can decide, sir. It can be go for SPWM or SBWM, vector control or sign PWM. That we can define, sir.
Yeah, sure. So in previous one more circuit diagram, I saw the previous one first black diagram. So he on that place, you're talking about the DC to DC converter and also rectifier. Maybe a converter, not starting, sir. Maybe starting. Yeah, here, sir. This one. So here, you're taking the battery that is from DC and also you're using the DC to DC converter and also rectifier.
Correct, sir.
So I don't know what purpose you're using the DC to DC converter and also rectifier. Maybe this coming to boost converter.
Yes, sir. It's depend on. For example, like it's a research application, correct, sir? So in research point of view, we need to test multiple machine with a multiple battery, correct?
Yeah.
So every time you can't go and change. For example, my battery is designed for 72 volt. Now, like in market, if you see the motors, so motors are coming with 60 volt also, 72 volts also, and 80 volt also. Some motor is coming with 110 volt also. So how will match this battery voltage with motor? If you have one application like, okay, this is like as I told, basic architecture. If you want, you can skip this DC-DC converter. You can connect battery with direct proportional drive, direct converter. No need to use the DC-DC converter.
Okay, so you can go directly also.
Yeah, in some special case, if you are working with SRM drive, so there we observe this converter is required for regenerative braking.
Exactly.
Yeah. So if you don't want to go for regenerative, directly you can connect battery to power drive. That is just based on application. So we are making as a standard because some drive is required, some drive is not required. So if you want, you can remove.
Yes, sir. Sir, and
it's
also
not compulsory.
Yeah, load side, only one-way communication or two-way communication, sir. Either from the motor, from the motor, you're going to give the supply to the grid, or from the grid also you're taking supply, sir.
It's bidirectional, sir. So for example, like if you want to load your EV motor, so that next machine induction has to work as a generator, correct?
Yeah.
If I have two, you just think in that way. We have two motor mechanically coupled back to back. If I want to load one machine, so one machine is already working as a motor. Now, if I want to load this, other has to work as a generator, correct?
Yeah.
Now generator is generating some power, so that power we are sending to grid. This is one. Other way, like if I want to send back power to battery, then my first machine, like my EV motor, has to work as a generator, correct, sir?
Yeah.
So next machine will work as a prime mover, so that we are using as a motor. So now we are taking power from grid to battery. It's a bidirectional operation, and that is possible in all like clockwise and anti-clockwise. So like this, we have 4 quadrant operation. One for clockwise, like loading, and regenerative, same for anti-clockwise.
Yeah, sir. And a small last one, sir. Sir, you're talking talk in terms of phases, either single phase and also two phase, three phase, 3-wire, 3-phase, 4-wire, and also you mentioned one slide itself, maybe 4 phases.
I explain, sir. Just 1 minute.
I think last.
Yes, power measurement. I got it, sir.
Yeah, I think 4 phases means I'm not exactly getting, sir. Like.
Yeah. So nowadays, like this is not 4 phase. I have seen, sir, up to 5 phase machine also. Here you can see, like our basic machine is 3 phase, correct?
Yeah,
But
exactly.
nowadays, some PMSM is coming with a three-phase also. Even recently, I saw in one of the industry and college, they are using five-phase machine. That is induction motor.
Which college, sir?
College name I not remember, but there is five-phase machine is there. I asked like, sir, why are you using five-phase machine? So in that mention is like, okay, so if you are working with a three-phase machine, if one of the phase gone means machine will turn off and it will draw high current and stalling condition. These all things they told. And if it's five-phase machine, if one of phase not there, if it's fail also, so motor will run but it will run with low efficiency. That's the things are there.
But basically, we're going to give the supply to only three-phase supply only.
Yeah, supplies three. See, nowadays, if I say very basic example, recently developed, like if you see VLDC fan, what is there? Input is three-phase supply, but there is inside, if you see control topology, inverter, everything, there is basically three-phase.
Yeah.
I can call as a three-phase VLDC, but these all are special DC machine only. Like it is required AC to DC converter. After then, once you have DC conversion, you can generate how many phase you want based on the topology: three-phase, four-phase, five-phase. So this is just to measure the power. If someone is working for four-phase or five-phase also, so we are providing the power panel.
I know very well about three-phase, up to three-phase, four-phase, sir. First time only I'm hearing that four phases. That's why I asked.
Yes.
Sir,
See,
and
three-phase four wire you can consider here. Like a three-phase means three phase and one neutral.
yes, not
Yes,
one. Transfer neutral
yes.
point is load point. That is coming to three-phase four wire.
Correct.
Yes, sir,
That
yes,
is
sir.
one thing.
Yeah, yes, sir. And sir, he entered your presentation very good. But here my doubt is, so here the people are talking about the AI-based electric vehicle. So where
Yes, sir.
the AI, sir, AI techniques, and also what are the necessity to use the AI techniques in this place? What are the better it's going to give them when compared to other controller by using AI? That is my simple question, sir.
You're talking about AI, artificial intelligence, correct, sir?
Yeah. Heading is they're given AI based. I think it is not related for you also. I
Yes,
haven't query about this one. AI based electric vehicle they're talking. So enter
yes.
presentation like your different controllers and different algorithms and also different
Correct.
converters.
Correct.
It's
Yes,
exactly what they're going to use and also feature also already you explained. Now,
Yes, sir.
so it is very good technology is going on. I don't know why the people are going to talk about AI based electric vehicle. So what are the main application of AI is coming in electric vehicle? And why they're talking about the AI in the electric vehicles? What are the parameters they're going to consider? Also, the same question I asked in the yesterday presentation also, but I did not receive any proper reason. That's why I'm asking the same question here.
Okay, sir. I have one of test case, so I can discuss with you. Hope it will clear your doubt. So nowadays, if you see like a current scenario is, if you want to, as I today I'm discuss sensorless control, correct?
Yeah.
So if you want to work with sensorless, for you can take example of any motor. So if I want to work, I need some motor parameter to estimate the rotor position, correct?
Yeah.
But nowadays, like that motor is coming from some manufacturer, and they also don't know I don't know, like they don't want to share or they don't have. So that scenario is background story, but we don't have data of motor. Now you think like how you will operate this motor with sensorless control without any data. Like some data we can estimate like resistance and inductance and some ways are there, but still we need some more data to go for accurate and more precise control, correct? So now what, for example, if you heard about ANN, like neural network control.
Yes, sir, exactly.
So what we are doing, we are generating some test case. Okay, this is the input for this particular input. For example, motor is designed for 220 volt. Ideally, if I apply 110 volt, motor has to run for half of the speed, correct? Practical is different. So like this, we have to do some test case and we have to prepare input output, some tables, some data we have to collect. That data we have to train it neural network, or you can go for AI also. So now no need to go for manufacturer or anyone. Directly you have some input output data. Inside we have some black box. There is nothing. It like that box don't know what is the motor. It's know only for this input I need to generate. This is the output. For example, if my reference is 100, it has to generate 1000 is the output. That's all. So in this way, if you are going to develop some algorithm without knowing the hardware, just as a black box, some multiple thought like, okay, sometime like I need to define my condition. So in algorithm is way up, but AI is kind of a decision making parameter there. it will decide like what I have to select. For example, I am using two sources here, battery and a supercapacitor. So we need to define what, like when I have to use battery and when I have to use supercapacitor. And once it's discharged, when I need to charge the supercapacitor without a power waste or other thing. And that is called efficient control, efficient way to operate the vehicle. So in
So
that will who will decide these all things, because someone has to be monitor the thing, someone has to give the command, someone has to decide the our predefined condition.
Mm.
And other thing, I heard just like nowadays they are improving our cloud system. So whatever the data continuously they are mounting, they are uploading, and based on this they are improving device days our EVs vehicles like batteries, BMS, and other, like you can say motor drive. And see, if you want to understand the any vehicle, so why is failing? So for that we need some real-time data, that failure condition. So who will capture this data? So AI will help out in this somehow. So compared to because we can't predict all conditions. So sometime AI will do smart work and will capture the signal, and it will help you out to for post analysis. It will
okay,
generate more and more predefined cases.
okay,
I
sir.
know this much only, so hope it's clear.
Yes, sir, yes, sir. Thank you very much, sir.
Okay, thank you.
Sir, and sir, are you going to give any training for internship for the students, sir?
Our training part is there, sir.
Okay, you're going to allow any students for final year students for internship.
Yes, sir.
Okay, sir. Thank you, sir.
Okay, sir. Thank you, sir.
On behalf of everyone here, I extend my heartfelt gratitude to Gajendra Singh, Senior Technical Engineer at Entopal Technology, for taking his time to share his invaluable expertise with us on the topic of electric vehicle simulation with MATLAB. Your enlightened presentation has provided us a deep understanding on various topics such as EV drivetrain, powertrain, FPGA real-time controllers, the hardware, sensors, and model-based designs, and also the VIVAC suite on how to simulate electric vehicles and get the desired output. Your insight into MATLAB application in EV simulation has not only expanded our technical horizon, but also motivated us to provide, to push to the boundaries of our learning research. Thank you once again, sir, for
Thank you,
sharing.
sir. Thank you, sir.
Yes.